Deep-sea exploration is the investigation of physical, chemical, and biological conditions on the seabed for scientific or commercial purposes. Deep-sea exploration is considered as a relatively recent human activity compared to the other areas of geophysical research, as the depths of the sea have been investigated only during comparatively recent years. The ocean depths still remain as a largely unexplored part of the planet and form a relatively undiscovered domain. In general, modern scientific deep-sea exploration can be said to have begun when French scientist Pierre Simon de Laplace investigated the average depth of the Atlantic Ocean by observing tidal motions registered on Brazilian and African coasts. He calculated the depth to be 3,962 meters, a value later proven quite accurate by soundings measurement. Later on, with increasing demand for submarine cables installment, accurate soundings was required and the first investigations of the sea bottom were undertaken. First deep-sea life forms were discovered in 1864 when Norwegian researchers obtained a sample of a stalked crinoid at a depth of 3,109 meters. The British government sent out the Challenger expedition in 1872, which discovered 715 new genera and 4,417 new species of marine organisms over the space of 4 years. The first instrument used for deep-sea investigation was the sounding weight used by British explorer Sir James Clark Ross. With this instrument, he reached a depth of 3,700 meters in 1840. The Challenger expedition used similar instruments called Bailey's sounding machines to extract samples from the seabed. In 1960, Jacques Piccard and U.S. Navy Lieutenant Donald Walsh descended in the Bath of Scafie Trieste into the Mariana Trench, the deepest part of the world's oceans, to make the deepest dive in history, 10,915 meters. On the 25th of March 2012, filmmaker James Cameron descended into the Mariana Trench and, for the first time, is expected to have filmed and sampled the bottom. History. Throughout history, scientists have relied on a number of instruments to measure, map, and observe the ocean's depths. One of the first instruments used to examine the seafloor was the sounding weight. Ancient Viking sailors took measurements of sea depth and sampled seafloor sediments with this instrument, which consisted of a lead weight with a hollow bottom attached to a line. Once the weight reached the sea bottom and collected a sample of the seabed, the line was hauled back on board ship and measured in fathom. Cornelius Drebbel, a Dutch architect, is generally given credit for construction of the first submarine. His submersible boat consisted of a wooden frame sheathed in animal skin. Oars with its openings were sealed with tight-fitting leather flaps, extended out the sides to propel the craft through the water, at depths up to 4.6 meters. Drebbel tested his submarine in the Thames River in England in sometime between 1620 and 1624. It is believed that King James I enjoyed a short ride in the craft. However, the nature of the deep ocean remained an unrevealed mystery until the mid-19th century. Scientists and artists alike imagined the deep sea as a lifeless soup of placid water. French author Jules Verne, who helped pioneer the science fiction genre, portrayed the deep ocean as contained in a bowl of static rock in his 20,000 Leagues Under the Sea. By the late 1860s, controversial modern scientific theories, the origin of life by evolution and the enormity of geologic time had created a foundation of scientific curiosity and provoked a rising interest in marine exploration. The Royal Society of England thus initiated an ambitious oceanographic mission to expand a scarce collection of existing marine data that included Charles Darwin's observations during the voyage of the HMS Beagle, a bathymetric chart created by U.S. Navy Lt. Matthew Maury to aid installation of the the first transcontinental telegraph cables in 1858, and a few examples of deep marine creatures. From 1872 to 1876, a landmark ocean study was carried out by British scientists aboard HMS Challenger, a sailing vessel that was redesigned into a laboratory ship. The HMS Challenger expedition covered 127,653 kilometers, and shipboard scientists collected hundreds of samples, hydrographic measurements, and specimens of marine life. They are also credited with providing the first real view of major seafloor features such as the deep ocean basins. They discovered more than 4,700 new species of marine life, including deep-sea organisms. Deep-sea exploration advanced considerably in the 1900s thanks to a series of technological inventions, ranging from sonar system to detect the presence of objects underwater through the use of sound to manned deep-diving submersibles such as DSV. Alvin, operated by the Woods Hole Oceanographic Institution. Alvin is designed to carry a crew of 3 people to depths of 4,000 meters. The submarine is equipped with lights, cameras, computers, and highly maneuverable robotic arms for collecting samples in the darkness of the ocean's depths. However, the voyage to the ocean bottom is still a challenging experience. Scientists are working to find ways to study this extreme environment from the shipboard. With more sophisticated use of fiber optics, satellites, and remote control robots, scientists one day may explore the deep sea from a computer screen on the deck rather than out of a porthole. Milestones of deep-sea exploration. The extreme conditions in the deep sea require elaborate methods and technologies, which has been the main reason why its exploration has a comparatively short history. In the following, important keystones of deep-sea exploration are listed. 1521, Ferdinand Magellan tried to measure the depth of the Pacific Ocean with a 2,400 feet weighted line, but did not find bottom. 1818, the British researcher Sir John Ross was the first to find that the deep sea is inhabited by life when catching jellyfish and worms in about 2,000 meters depth with a special device. 1843, nevertheless, Edward Forbes claimed that diversity of life in the deep sea is little and decreases with increasing depth. He stated that there could be no life in waters deeper than 550 meters, the so-called abysses theory. 1850, near the Lofoten, Michael Sars found a rich deep-sea fauna in a depth of 800 meters, thereby refuting the abysses theory. 1872 to 1876, the first systematic deep-sea exploration was conducted by the Challenger expedition on board the ship HMS Challenger led by Charles Wyville Thomson. This expedition revealed that the deep-sea harbors a diverse, specialized biota. 1890 to 1898, first Austrian-Hungarian deep-sea expedition on board the ship SMS Polar led by Franz Steindarkner in the eastern Mediterranean and the Red Sea. 1898 to 1899, first German deep-sea expedition on board the ship Valdivia led by Carl Chun, found many new species from depths greater than 4,000 meters in the southern Atlantic Ocean. 1930, William Beebe noted Spartan of the first humans to reach the deep sea when diving in the so-called bathysphere, made from steel. They reach a depth of 435 meters, where they observed jellyfish and shrimp. 1934, the bathysphere reached a depth of 923 meters. 1948, Otto Spartan set out for a new record reaching a depth of 1,370 meters. 1960, Jacques Piccard and Don Walsh reached the bottom of the Challenger deep in the Mariana Trench, descending to a depth of 10,740 meters in the deep-sea vessel Trieste, where they observed fish and other deep-sea organisms. 2012, the vessel Deep-sea Challenger, piloted by James Cameron, completes the second manned voyage and first solo mission to the bottom of the Challenger Deep. Oceanographic instrumentation. The sounding weight, one of the first instruments used for the sea bottom investigation, was designed as a tube on the base which forced the seabed in when it hit the bottom of the ocean. British explorer Sir James Clark Ross fully employed this instrument to reach a depth of 3,700 meters in 1840. The sounding weights used on the HMS Challenger were slightly advanced, called Bailey sounding machine. The British researchers used wireline soundings to investigate sea depths and collected hundreds of biological samples from all the oceans except the Arctic. Also used on the HMS Challenger were dredges and scoops, suspended on ropes, with which samples of the sediment and biological specimens of the seabed could be obtained. A more advanced version of the sounding weight is the gravity corer. The gravity corer allows researchers to sample and study sediment layers at the bottom of oceans. The corer consists of an open-ended tube with a lead weight and a trigger mechanism that releases the corer from its suspension cable when the corer is lowered over the seabed and a small weight touches the ground. The corer falls into the seabed and penetrates it to a depth of up to 10 meters. By lifting the corer, a long, cylindrical sample is extracted in which the structure of the seabed's layers of sediment is preserved. Recovering sediment allows scientists to see the presence or absence of specific fossils in the mud that may indicate climate patterns at times in the past, such as during the Ice Ages. Samples of deeper layers can be obtained with the corer mounted in a drill. The drilling vessel JOIDES Resolution is equipped to extract cores from depths of as much as 1,500 meters below the ocean bottom. Echo sounding instruments have also been widely used to determine the depth of the sea bottom since World War II. This instrument is used primarily for determining the depth of water by means of an acoustic echo. A pulse of sound sent from the ship is reflected from the sea bottom back to the ship, the interval of time between transmission and reception being proportional to the depth of the water. By registering the time lapses between outgoing and returning signals continuously on paper tape, a continuous mapping of the seabed is obtained. The majority of the ocean floor has been mapped in this way. In addition, high-resolution television cameras, thermometers, pressure meters, and seismographs are other notable instruments for deep-sea exploration invented by the technological advance. These instruments are either lowered to the sea bottom by long cables or directly attached to submersible buoys. Deep-sea currents can be studied by floats carrying an ultrasonic sound device so that the movements can be tracked from aboard the research vessel. Such vessels themselves are equipped with state-of-the-art navigational instruments such as satellite navigation systems and global positioning systems that keep the vessel in a live position relative to a sonar beacon on the bottom of the ocean. Oceanographic submersibles. Because of the high pressure, the depth to which a diver can descend without special equipment is limited. The deepest recorded made by a skin diver is 127 meters. Revolutionary new diving suits, such as the gym suit, allows divers to reach depths up to approximately 600 meters. Some additional suits feature thruster packs that boost a diver to different locations underwater. To explore even deeper depths, deep-sea explorers must rely on specially constructed steel chambers to protect them. The American explorer William Beebe, also a naturalist from Columbia University in New York, was the designer of the first practical bathysphere to observe marine species at depths that could not be reached by a diver. The bathysphere, a spherical steel vessel, was designed by Beebe and his fellow engineer Otis Barton, an engineer at Harvard University. In 1930, Beebe and Barton reached a depth of 435 meters and 923 meters in 1934. The potential danger was that if the cable broke, the occupants could not return to the surface. During the dive, Beebe peered out of a porthole and reported his observations by telephone to Barton, who was on the surface. In 1948, Swiss physicist Auguste Piccard tested a much deeper diving vessel he invented called the bathysphere, a navigable deep-sea vessel with its gasoline-filled float and suspended chamber, a gondola of spherical steel. On an experimental dive in the Cape Verde Islands, his bathysphere successfully withstood the pressure on it at 1,402 meters, but its body was severely damaged by heavy waves after the dive. In 1954, with this bathysphere, Piccard reached a depth of 4,000 meters. In 1953, his son Jacques Piccard joined in building new and improved bathysphere, which dived to 3,139 meters in field trials. The U.S. Navy acquired Trieste in 1958 and equipped it with a new cabin to enable it to reach deep ocean trench. In 1960, Jacques Piccard and Navy Lieutenant Donald Walsh descended in Trieste to the deepest known point on Earth, the Challenger Deep in the Mariana Trench, successfully making the deepest dive in history, 10,915 meters. An increasing number of occupied submersibles are now employed around the world. The American-built DSV Alvin, that is operated by the Woods Hole Oceanographic Institution, is a three-person submarine that can dive to about 3,600 meters and is equipped with a mechanical manipulator to collect bottom samples. Alvin made its first test dive in 1964 and has performed more than 3,000 dives to average depths of 1,829 meters. Alvin has also involved in a wide variety of research projects, such as one where giant tube worms were discovered on the Pacific Ocean floor near the Galapagos Islands. Unmanned submersibles. One of the first unmanned deep-sea vehicles was developed by the University of California with a grant from the Allan Hancock Foundation in the early 1950s to develop a more economical method of taking photos miles under the sea with an unmanned steel high-pressure 3,000-pound sphere called the benthigraph, which contained a camera and strobe light. The original benthigraph, built by USC, was very successful in taking a series of underwater photos until it became wedged between some rocks and could not be retrieved. ROVs, or remote-operated vehicles, are seeing increasing use in underwater exploration. These submersibles are piloted through a cable which connects to the surface ship, and they can reach depths of up to 6,000 meters. New developments in robotics have also led to the creation of AUVs, or autonomous underwater vehicles. The robotic submarines are programmed in advance and receive no instruction from the surface. HROV combine features of both ROVs and AUV, operating independently with a cable. Argo was employed in 1985 to locate the wreck of the RMS Titanic. The smaller Jason was also used to explore the shipwreck. Scientific results. In 1974, the Alvin, the French bathysphere Archimede, and the French diving saucer Cyan, assisted by support ships, and the Glomar Challenger, explored the Great Rift Valley of the Mid-Atlantic Ridge, southwest of the Azores. About 5,200 photographs of the region were taken, and samples of relatively young solidified magma were found on each side of of the central fissure of the Rift Valley, giving additional proof that the seafloor spreads at this site at a rate of about 2.5 centimeters per year. In a series of dives conducted between 1979–1980 into the Galapagos Rift, off the coast of Ecuador, French, Italian, Mexican, and U.S. scientists found vents nearly 9 meters high and about 3.7 meters across, discharging a mixture of hot water and dissolved metals in dark, smoke-like plumes. These hot springs play an important role in the formation of deposits that are enriched in copper, nickel, cadmium, chromium, and uranium.